could a lasting home be carved directly into a steep hillside with nothing but hand tools? She starts by widening a raw cavity in the dense, reddish-brown earth. This compacted soil provides a naturally stable foundation, resisting immediate collapse as the footprint expands. With the initial alcove established, the focus shifts to load distribution. A solid structural base requires more than just packed dirt. She begins arranging rough, heavy stones around the perimeter of the pit. Stacking dry stone demands careful selection. Each rock must seat firmly against its neighbors without mortar. By sinking corner supports directly into the subsoil, she ensures the coming walls won't shift under the weight of heavy rains. To lock the loose stones together, she introduces a thick clay binder. When wet mud cures between the rocks, it essentially creates a unified, monolithic masonry ring. A small fire tests the airflow of the new masonry. Heating the surrounding clay also accelerates the curing process. As the moisture bakes out, the earthen mortar hardens into a rigid, fire-resistant shell. Moving upward, the project transitions to timber framing. Using a handsaw and machete, the builder shapes raw branches into structural supports. Working with green wood requires an understanding of its natural flex. The heavy primary beam spans the width of the alcove, anchoring the entire roof load. She pins smaller, lighter rafters across it at regular intervals. Securing these poles with forged nails, he creates a rigid skeleton that ties the earthen walls together. The angled pitch is crucial here. Without a significant slope, accumulated debris and water could easily bow the natural timber over time. To waterproof the canopy, a continuous sheet of clear plastic is stretched taut. Securing the edges tight against the wooden frame prevents the wind from catching and tearing the membrane. But a roof is only half of a moisture management system. She immediately cuts a small drainage trench around the exterior perimeter. This vital channel intercepts ground runoff, diverting water away from the foundation before it can pool inside. Final weatherproofing means sealing every draft. Thick mud is daubed deeply into the crevices of the stone foundation, acting as a windbreak and natural insulation. The timing proves critical as the forest canopy darkens and heavy rain sets in. Sudden downpours are the ultimate stress test for any wilderness build. A single flaw in the roof pitch or exterior trenching would funnel water directly into the living space. The rain drumming on the pond outside confirms the environment's unforgiving nature. Inside, the shelter holds its own against the deluge. The heavy mass of the earth and stone walls dampens the sound of the storm. Even in this rough state, the subterranean footprint captures heat effectively. However, the narrow gaps left in the roofline allow ambient light to filter through, revealing exactly where the structural vulnerabilities lie. She immediately targets those weak points, packing dense, wet clay between the wooden support poles, and the masonry closes the envelope. This localized daubing acts as both a flexible gasket and a structural adhesive. As the clay dries, it shrinks slightly, gripping the rough bark to form a permanent, airtight seal against the draft. With the floor smooth, she shifts to enclosing the exposed front. Heavy wooden stakes are driven deep into the ground to anchor the exterior facade. A series of horizontal wooden slats drop into this framework. Stacking these boards edge to edge creates a solid physical barrier that defines the boundary between the wild forest and the controlled interior. A pre-assembled wooden door frame completes the enclosure. Fitting this rigid square exactly into the organic shape of the earthen walls requires careful alignment, transforming a mere alcove into a secure cabin. To ensure complete integration with the landscape, the roof is blanketed under a thick layer of soil. This living roof provides massive thermal mass, regulating interior temperatures against the extremes of day and night. It also completely camouflages the structure from above. Stepping inside, the true value of the labor becomes clear. With a simple battery lamp illuminated, the packed earth walls reflect a warm glow. The compact space is highly efficient, requiring very little energy to keep warm. Every stone placed and timber cut has contributed to this singular outcome, a dry, secure anchor point in an unpredictable environment. Having a functional base camp drastically changes the logistics of survival. It allows the builder to rest, store tools safely, and plan the next phase without constant exposure to the elements. With a secure base established, the ambition scales up. She initiates a massive secondary excavation, carving a deep, rectangular trench directly into the clearing. This requires brute, sustained physical endurance to break through the dense root systems. The new trench will serve as an extensive underground corridor. To prevent the exposed earth from caving in at the threshold, she reinforces the entrances with a heavy masonry arch. Flat, weathered stones gathered from the stream are stacked tightly to form a durable collar. She binds them with thick mud, packing the wet earth deep into the joints. The curved profile of the entrance is particularly important. Rounded tunnel shapes distribute compressive forces from the earth above far more efficiently than flat lintels. The resulting stone ring stabilizes the most vulnerable section of the deep cut. An underground tunnel requires a roof capable of supporting immense dead weight. She selects straight, robust timber for the primary crossbeams. Using a machete and handsaw, she carefully notches the ends of the logs. These interlocking joints will prevent the roof supports from rolling under pressure. Precision at this stage dictates the safety of the entire subterranean structure. Each beam is sized to span the trench perfectly, resting flush against the solid dirt walls. The assembly of the tunnel roof relies on volume and redundancy. Dozens of uniform logs are laid tightly across the span, creating a continuous wooden deck. Once the timber skeleton is in place, she introduces a thick buffer layer of dry grass. This organic mat serves a dual purpose, prevents the loose soil from falling through the gaps, and it adds a crucial layer of dead air insulation. With the barrier set, she begins the grueling process of burying the entire structure. Shovel by shovel, the excavated dirt is piled heavily over the log roof. The weight compresses the grass mat, locking the timber framing firmly into the earth. By meticulously smoothing and leveling the topsoil, the massive trench completely disappears. What was a gaping wound in the forest floor is restored to a flat grade, seamlessly swallowing the architecture below. Down in the cramped darkness of the newly buried tunnel, the structural work continues. Even highly compacted earth walls carry a risk of shearing or sloughing over time. To brace against soil creep, she wedges stout vertical logs directly against the dirt faces. These upright pillars act as internal shoring, holding back the lateral pressure of the surrounding ground. Operating in this narrow corridor is claustrophobic, but securing the perimeter ensures the space remains safe for long-term habitation. Back at the surface, the exposed mouth of the tunnel needs a rigid framework. She measures and cuts custom lengths of timber to frame the rectangular opening. Instead of relying solely on joinery, she binds the corners tightly with durable string, lashing the wood into an unyielding square. To lock this collar into the landscape, wooden stakes are driven violently into the subsoil. The finished entrance frame acts as a hard boundary, preventing loose topsoil from washing the wall down into the subterranean corridor. It establishes a clean, protected transition zone. To secure that entrance, a flexible, custom cover is required. She systematically saws branches down to perfectly uniform lengths, ensuring each piece will span the tunnel opening without unnecessary overhang. These identical cuts are then lashed side by side using tight knots. This traditional technique creates a rollable timber mat. It forms a heavy-duty wooden curtain flexible enough for daily use, yet strong enough to keep out debris. A truly hidden shelter must breathe and grow with its environment. She transplants living patches of native grass directly into the loose topsoil covering the roof. The roots will quickly spread and interlock, acting as a natural rebar that binds the earth together. This living mesh prevents severe erosion during monsoon rains. More importantly, as the vegetation takes hold, the distinct geometry of human construction is erased, swallowed entirely by the green chaos of the forest floor. Airflow is the invisible engine of any underground habitat. Without proper ventilation, moisture and stale air rapidly accumulate, turning a shelter into a stifling hazard. Using a long-handled spade, she drives a vertical shaft deep into the earth. This new excavation will act as the lungs of the entire complex. Working At the bottom of the deep shaft, the excavation requires absolute precision. She uses the edge of the spade to carve a deliberate niche into the vertical wall. This isn't just removing dirt, it's shaping an engineered airway. The highly compacted soil allows her to bore a smooth tunnel sideways without the immediate threat of a cave-in. Kneeling in the shadowed pit, she inspects the connection point. A clean, unobstructed bore is essential. Even a minor collapse inside this narrow pipe would choke off the oxygen supply. The dark hole now bridges the deep tunnel with the open forest, establishing a passive draft system driven entirely by temperature differences in the earth. To protect this vital airway from rainfall, a protective cowl is constructed. She bridges the surface opening with a flat, sturdy stone, then builds up a small masonry chimney using mud and rocks. This elevated collar ensures that surface water runoff won't flood down the shaft. A smudge fire at the base proves the concept. Thick white smoke is drawn up and out of the stone chimney, confirming a strong, continuous updraft has been successfully established. With the raw earthworks complete, the focus shifts to interior finishing. She harvests thick, mature bamboo stalks from the surrounding groves. Bamboo offers an exceptional strength-to-weight ratio, making it the perfect material for lightweight, resilient architecture. Every joint in a bamboo structure must be custom-shaped. Using a heavy knife, she carves precise, interlocking notches into the green wood. These carved tension points allow the rigid stalks to be bent and bound without snapping the fibers. Once the curved bamboo ribbing is locked into place, the tunnel requires its final layer of insulation. She layers massive bundles of dry brush directly over the skeletal frame. This dense thatch acts as a porous cushion, preventing the heavy roof soil from falling through the bamboo grid. It also creates a critical air gap to trap heat. Next, heavy shovelfuls of loose dirt are spread evenly across the brush. The weight of the earth compresses the thatch down into a weather-resistant barrier, seamlessly blending the roofline back into the natural contour of the hill. A final coating of wet clay seals the exterior surface, locking the loose soil in place. Pressing dry grass into the wet mud fortifies the crust, turning the roof into a hardened, erosion-proof shell. She rigorously tests the completed bamboo entrance frame. Tolerances must be exact. Any shifting at this critical juncture could compromise the stability of the entire front facade. From the outside, the architecture vanishes into the hillside, betrayed only by a small, shadowed threshold. But stepping through that entrance reveals a completely transformed world. The curved bamboo walls soften the raw earth, creating an enclosed sanctuary. As darkness falls outside, a single lantern casts a warm yellow glow across the bamboo. The light highlights the immense precision of the interior wrap. Under the bright wash of an LED light, the true scale of the achievement is unhidden. What began as a muddy pit is now a meticulously clean, highly organized subterranean dwelling. In the end, raw earth, woven timber, and daily routine operate as one system, a hidden outpost that produces, protects, and sustains itself.